So on question 11, they like to ask us in piecewise function. You'll notice that they give us a lot of piecewise function. So our technique to see our piecewise function clearly is using our interval. We didn't draw the graph, at least we jot down our function, which is at the left hand side, which is at the right hand side. So first, they ask us to find the limit at x equals to 4. So before we start answering our question, we jot down our function. For x, 4. When you have not equals to 4, means it left hand side and right hand side, they are same. They are same function actually. But on the interval x equals to 4, this is a point number 40. So therefore, when we see the situation here, left hand side, right hand side, same function. So when we want to find our first question, limit for x approaches 4, we can directly use our function. We don't need to do left hand side and right hand side, because left hand side this function, right hand side this function, the function is same. We are substitute the same things. We are simplifying the same things. Also, of course, they will exist. So we directly use limit x equals to 4 straight away to find out the answer. So when we're doing this limit, we substitute x equals to 4 here, we'll notice that we have 0 over 0 IDF. So in order to solve this polynomial, we can see this is improper fractions. S cubed is bigger than linear. So what can I do here is we doing our long division in order to simplify our function. So x cubed, we don't have x squared, so we put 0. We don't have x, we put 0. Divide by x minus 4. So we need an x squared here to get x cubed. Then we minus put a 4x in order to get 4x squared. Then we minus our balance here, it gives you 16. So we need a 16 here. So therefore our limit when x approaches 4, after our long division, our quotient is x squared plus 4x, then plus 16. And then remainder, oh, so we don't have remainder. So we don't have remainder, so we just have this function only. We don't have any remainder, we can divide it completely. So we attempt to solve our limit again, substitute our x equals to 4 here, will become 4 squared plus 4 times 4 plus 16. So we get answer of 48. And then they ask us question 2. Is it continuous as x equals to 4? So when you want to determine whether it is continuous or not, so we must make sure the 3 conditions, it must be fulfilled. So for part 2, the first condition, is it the point axis? F4, is it axis? S4 is 40, so it is defined. Then condition number 2, is it the limit axis? The limit when x approaches 4 is its axis, we get 48. So condition number 3, is it the point and the limit approaches x equals to 4 same? So definitely it's not same. So condition 3 does not fulfill. F4 does not equal to the result of limit in condition 2. So we can come up a conclusion that this function is not continuous at x equals to 4. Give your reason, because it didn't fulfill our condition number 3, because f4 does not same with limit when x approaches 4 for the functions. So this is our part A. So the first part will be finding our limit x equals to 4. So this is the concept of we simplify. We simplify our polynomial and then we find out our limit to get to the answer. The second part is asking about continuity. So step by step, condition by condition, we need to show it out. This is our first condition fulfilled. Second condition also fulfilled. But third condition is not fulfilled. So our answer does not exist. So the reason will be dropped down to here because it does not same. Okay. Okay, we continue to question B. So question B, they also give us a new piecewise function. So they say determine the value of AB such that it is continuous. So it already mentioned it continuous. So we just want to make sure the left hand side equals to right hand side. Then the function can be continuous. So when we meet a situation of piecewise, so our first step always is draw out the interval. So x less than -1 is a function ax minus b. Okay, x less than -1, ax minus b. -1 until 1. -1 until 1, it is 2x squared plus 3ax minus b. And then when x more than 1, is its value of 4. So to make sure it is continuous means our limit when x approaches -1, because it has different functions here, we have to make sure the limit from the left and from the right, they are equal. And then we can see our another changing function at x equals to 1. So we have to make sure the function, the limit from x approaches 1 from the left hand side and 1 from the right hand side, their limits is equal so that it can continuous for all the value of x. So it can continuous from left hand side to all the right hand side. So we do for the first part here, which is our changing function at the point x equals to -1. We build out the continuity here, which is x approaches -1 on the left hand side. Function ax minus b definitely need to equal for x approaches 1 from the right, -1 on the right hand side, where our function is 2x squared plus 3ax minus b. So we try to simplify this equation. Substitute our 1, we can get a simultaneous equation, I think. So here we substitute, this is -a. So here it will be 2 minus 3a minus b. So simplify our equation, we rearrange here, move the a to the right hand side. So plus 3, yes. So I have a writing typo here, this is plus b. Okay, so that's why when we jot down here, we have to do it carefully. Okay, so plus b, so here is plus b. Simplify, 3 move to the right hand side to a. This b move to the left hand side here, -2b equals to 2. So a minus b equals to 1, first equation. Then we continue to another point, which is x equals to 1. Limit for x approaches 1, left hand side, equal limit x approaches 1, right hand side, 4. So substitute 1 inside. And then simplify it. 3a plus b equals to 2. Okay, so we will solve these two simultaneous equations. Then we notice that negative b, they are similar. So our operation to solve our simultaneous here will be 2 plus 1. So that our b can be eliminated. So here we get 4a. B we eliminate, we find our a. So plus it together, it is equal to 3. So a is equal to 3 over 4. Then we substitute into either one. So I pick equation 1. 3 over 4 minus b equals to 1. So b equals to 3 minus 4 minus b equals to negative 1 over 4. So our task complete here, which is find our AB. So our concept here will be the first part. Make sure our limit left hand side equals to right hand side. And then this is another concept. For the point x equals to 1, then we're forming these two equations. So solve our simultaneous equation to get to the answer.